All right, welcome to video 2 of basic anti-derivative rules, anti-differentiation, if you will. I asked you to think about how to do C and F here. Did you think of a function whose derivative is 3x squared? If you said x to the third, you would be correct, but don't forget, put the plus c, and now you have a complete antiderivative, or an indefinite integral. They mean the same thing. Ooh, what about letter F here? What would that equal? Let's see. What do you think? What do you think? So if you said 4/3 x to the third, well, then you would be correct, plus c. Now, before I move on, what's a shortcut to this? We're basically undoing the product rule, right? And if you remember the product rule, I'm sorry, not the product rule, the power rule. The power rule said if you have a power function and you're taking the derivative, you take the exponent, you multiply it times the power minus 1. Okay? So then if I'm looking to take the antiderivative, why don't I do things backwards? The last thing I did here was take away 1 from the exponent. I subtracted 1. Why don't I add 1 to the exponent? And then instead of multiplying, I'm going to divide. So if you think about it, if you add 1 to the exponent, I got my new exponent. Oh, here, let me do it over here on the side. I'm going to add 1 to the new exponent. The 3 was already there. Add 1 to the exponent, and then I'm going to divide by the new exponent. Oh, that's going to reduce the 3's, and I'm left with x to the third. I can do the same thing here. I'm going to add 1 to the exponent, divide by the new exponent, and then that's how I got 4/3 pi to the third. So there is a reverse power rule that just does the opposite operations in reverse order of the power rule, right? First, in the regular power rule, in the regular power rule, we multiplied and then we subtracted 1 from the exponent. So go backwards, add 1 to the exponent and divide by the new exponent. And that's one of the rules that I'm going to ask you to write down, and one of the rules that we're going to need in order to take antiderivatives quickly. So that is under number 4. Number 4 is a power function. So notice how this symbol is like a definite integral, except there are no limits of integration. So when there are no limits of integration, we call that an indefinite integral. And an indefinite integral means find the antiderivative. So the antiderivative of u to the n would be u to the n plus 1. We're going to add 1 to the exponent and then divide by the new exponent, which is n plus 1. Now, this works as long as n, this exponent, is not negative 1. Well, what if it is negative 1? Well, if it's negative 1, like number 5, this is the same thing as this, and that has its own rule. That would be the natural log of the absolute value of u. Oh, plus c, same thing here, plus c. The antiderivative of e to the u, that would be e to the u plus c. The antiderivative of cosine u, that would be sine u plus c. And then the antiderivative of sine u would be negative cosine u plus c. So these are rules you're just going to have to know, right? These are the rules that are the reverse of the rules you learned in the fall semester. Now in the spring semester here, we're just going forward, backwards. But we're just reversing everything that we talked about. Notice that all the formulas above are in terms of u. This is going to lead us to something that we call u substitution. And u substitution is going to help whenever we realize this could be a function, this u could be a function on itself, and it could be an inside function. So u substitution that we're going to learn later is going to be the integrals version of the chain rule with derivatives. So what you did with the chain rule we are going to undo the chain rule with something called U substitution. And that is going to be a fun time, I will tell you. Okay, a couple of things to remember. Um, Before you do the rules, turn any radicals into fractional exponents. Remember how we can take, for example, the cube root of x to the second is the same thing as x to the 2/3 power. That's going to help immensely to do the reverse derivatives, the antiderivatives. And then no variables in the denominator. Just like taking derivatives, we cannot do integrals in the denominator. Denominator. So we're going to have to move it to the numerator if necessary. So if you have something like this, 1 over x to the 5th, I can't do the reverse power rule here. I have to rewrite it, and then I can do the reverse power rule to figure out the antiderivative. So 2 things to remember, just like before. In the next video, we'll do some from example 2 and example 3 to kind of get a feel for using these antiderivative rules.